Good afternoon. So I'm going to address a very simple topic at 3 in the afternoon, the second day of the conference, at the time of the nap, security. Security in IoT and how we see security not as a pure cost, but more as an opportunity to generate new revenue stream into IoT. And moving from M2M to Internet of Things, so connecting everything. And the tagline of the event is the fascinating, or the fascination for IoT. Yes, indeed. Connected objects are all around us in the streets, in your cars, in your pocket, in your home, everywhere. And there are plenty of service providers that are providing to you a bench of services that you might think as being a gadget today, but might be essential to your life tomorrow. So connecting everything, everywhere, whatever, from your grandma to your watch, going through your pajamas, your shoes, but more industrial, your cars, your some trucks, the digital signage into the streets. It comes with a lot of challenges in between the vision of IoT of today's up to the really developing and unlock the potential of IoT. There are, as Svetlana was saying, there are many challenges to unlock these opportunities. And it starts with a very large variety of type of connection, from ultra-narrowband, short range, cellular technology. And we are today far from the 50 billions of connected devices which has been announced 3 years ago already. We're a bit far there. So we have to be precise what a connected object is, what a smart object connected is. And in IoT, we are really moving from B2B to B2B to C. That comes as well with different challenges. At the end of the connection of the object, there is always a human being that is generating data with different type of objects. And reconciliating all this information from one individuals, you come with discovering plenty of information of his personal life. So data privacy has raised as one of the key elements to be solved for end users using connected objects. And these security concerns start with the privacy of the data for end users, but as well industries that are dealing with critical infrastructures, such as a car, or transport, trains, planes, cars, but as well as energy. So energy where you've got a hub in-house, which is connected to a utility, which is connected to power plant. So here we are dealing with critical infrastructure, and security is not just a thought and need to be implemented. But why connecting all the subjects? Today, the main value of IoT is how to generate new business models, how to generate new revenue streams. And moving from pure, I would say, industrial M2M to IoT, that means that you've got industries that will interconnect themselves thanks to those small objects. So security is not seen for us as a pure cost, but you will need to put trust into those objects and those infrastructure in order to generate new revenue streams. And the value of IoT lies into the data. And this value, the data are the values because you need to trust the data. It's proper data, genuine data. It's not fake information, because those information are made and are analyzed to take business actions. So that's in that context that security is not a cost in IoT, but might be perhaps the element that will help industries to trust each other and really generate the new revenue streams that are promised by the connected objects. So when you look at an end-to-end application or a connected object, it always start with a device, whatever it is. The information goes through a network or different type of networks, could be hybrid type of networks. Then those data are stored, then analyzed into a data center, into a cloud, and you've got a vertical application which is born now. But the big question in those infrastructure, whatever you're a big corporation or a startup or an SME, is where is the breach? Where is the security breach? How can I identify security vulnerabilities? How can I identify them and solve the problem? And what about the privacy of the data of my consumer? What about of the security of my own data that I'm using for my industry? So if we look at what Bicham research has mapped the security threats of the IoT, looks like extremely simple. So you've got plenty of different companies that are dealing around those circles, and you still have a device on the edge. You've got networks, you've got platform, you've got system operators to end at the end user. And what brings IoT there is the interconnection between different sectors. Here you can see in between industrial, transportation, retail, and security, public safety. You can potentially have one single object which is mixing those industries. So by the proliferation of devices, bringing plenty of use cases, we are, by essence, multiplying the source of vulnerability of an infrastructure. And then for certain companies, for certain industries, some of those security breaches need to be solved for whatever reason, guaranteeing the privacy of the data of end users, protecting itself against intrusion into the systems, preventing fraud, and as well being able to, I was speaking about data. If you interconnect a transport company, a utility, and a retailer through one single object, are those data reliable? Do I trust the three party, the three industry? How I can monetize this information? And to monetize the data is to be sure that I'm trusting those data. They are genuine, and they are giving me the proper information. So with this kind of ecosystem, as described, it's a tentative from Bicham, but it shows really the wild environment in which we are working, where all threats can be around each of the corner. Just to give you an example, concrete example of home automation. You've got hubs, and that's currently the battle to figuring out who's going to be the hub in the house. So it will be different from one country to another, or one end user to the other. You've got MNO that are providing, such as AT&T Digital Life. You've got broadband provider. You've got alarm system providers, but also home automation that are proposing a home hub, and this home hub to be connected on one hand to the utilities or to another industry, and on the other hand, connected to your personal objects, to your PC, to your tablet, to your fridge, to your washing machine, or to your lamp in your living room. So the home automation, you've got a hub, which is really doing the link in between consumer IoT and industrial M2M. So this type of application increase, which is one of the key markets which is growing up the past year, is extremely attractive for hackers, attractive for different reasons, whether it's cyber criminality, cyber terrorism, to use one of those devices as a backdoor to penetrate into the system which is at the other side, into the utility information system, or just for fraud. You just come up at the door of this house with a fake device, you connect through Wi-Fi to the hub, or through Bluetooth or Zigbee to the hub which is in the house, and this hub is connected through cellular to an information system. Any single non-authenticated devices could be a fake devices which is trying to penetrate into an information system. So as a small, medium, or a big corporation, you could say it's not because of a lamp that is connected to my mobile phone that I'm putting in danger the nuclear power plant, which is 30 kilometers ago. Well, if you don't look at how the things are done, might. And when just what I was saying, you see several vulnerabilities of what currently is putting on the market today. There are vulnerabilities across the ecosystem, in the network, on the device itself. I was speaking about fake devices that can, without any authentication, that can connect through Bluetooth or Zigbee to a hub in the house. You have a recent study, a report from HP is saying that for security alarm, 100% of the service providers that are bringing security alarm in home does not put as mandatory a login password to connect to the alarm. 100% of them. It's not mandatory. So basic login password, so it's a basic authentication of the user against the machine. None of them are putting that as mandatory. That give an idea of, even on good ideas, and the balance between the convenience and what you are connecting to, that give an idea where we are within security into current application, but also in the coming interconnected application in IoT. So how it can help to address security issues in IoT, and really, as I was saying at the beginning, not seeing security as a pure cost. I have to do it, so I'm doing it, and it's a cost. And it's a cost when I'm buying something, but it's a cost because it's consuming more energy, it's taking more time, it's complex, it's difficult, as Svetlana was saying. So how we can really help industries to put the right level of security. Putting excessive security into an infrastructure is useless. You just kill the business model. But figuring out what to protect, where to protect, and when to protect is one of the key elements. So that's the approach we've got in 3 steps. The first thing is to assess the security level and the security need of an infrastructure, not only on a small device, but the device in its environment. So it goes through risk evaluation. And this risk evaluation, you end up with that amount of documentation, which is highlighting vulnerabilities with the likelihood to happen, the consequences in the overall infrastructure. So it's security by design and the system, the security of the system, not only of a part of the infrastructure. So first, assessing security. When you have those amount of documentation that are highlighting security, then the industry in conscious is saying, balancing costs and risks, is saying, that breach, I solve it. That one, it's okay. I'm not risking that much, nor in operation, nor financial. It's a bit like in the US, that they are just migrating from, for payment card, they are just migrating from a basic plastic banking cards into a payment card with a chip inside. Only this year, while across Europe, it has started in 2000. So 15 years after. Why? Because it was a risk evaluation, balancing cost and risk. And as now the fraud of payment using plastic card is above the amount of additional cost to put cheap cards onto the field, they are migrating everything. So balance, cost, risk is key. And to balance correctly, you need to assess the security. And then what the second step, of course, is bringing security element, root of trust, encryption methods for the data, bringing authentication between end users and the different devices. So we've got a suite of security elements to help our customers to secure the vulnerabilities that they want to be solved, from the device to the infrastructure. And the third element, which is as key at the very first one, assessing the security level, speaking security by design, those devices are not on the field only for 1 year, 6 months, 2 years. Those infrastructure we are speaking about are going to be on field for 5, 10, 15 years. And the security countermeasures you put together today most likely will be obsolete in 5 years' time. So while securing by design and infrastructure, you need to think about handling the life cycle management of the security countermeasures that are put in place in this infrastructure. Being able to modify over the air security credentials, to make evolve the security level of your application. So 3 steps: assess the security need, protect what needs to be protected, and think about the lifecycle management of the security in the infrastructure. And only that will prevent industrial not to, in 5 years' time, to have a big announcement in the press and have to recall everything and to change every single smart meters or every recall cars. That will cost a fortune, because they did not thought 5 years ago that they might need to be able to make evolve the security level of their devices. So just an example of what we are doing, a risk evaluation, what it means and what is done in the automotive. Risk evaluation, you've got a car, and this famous connected car is not only speaking inside, so car makers are professional at securing inside the car what they need and the vital organs of the cars, but now connecting the cars, it's opening door to the external world. Opening the door to speak to another car, to speak to an end user, to speak to a street light, to speak to a signal panel on the road system. So it's potential backdoors. So you've got plenty of communication means, plenty of use cases, and you can penetrate and change information into a car. And it's a critical infrastructure. Recent publication in the press this summer shows how dramatic and what could be a consequence of a system intrusion in the car. So risk evaluation comes with an analysis of the risk, having this big test plan, so defining all what possible needs to be tested to figuring out if this is a genuine or not vulnerability, and then doing the evaluation. So testing in black box, in white box, okay, we are running the test plan and we are highlighting, yes, there is a security breach here. It was vulnerable, and in 1 day we can break it. Or it's never going to happen, really. There is a security breach, but you will have to put $1 million on the table and spend a team of 100% for 1 year to get one information. Perhaps I can live with it. Then the second step is putting in place the protections into the infrastructure. And again, it's protecting what matters and where it matters at 3 different levels. When you have to guarantee the privacy of the information, so encrypting data from the edge, so from the device, up to the system in which it's used, in a database, in a secure storage, in when those data are transiting from one company to another, so to ensure end-to-end security. And that the type of server and security means we are putting together into the back end of enterprises' connected devices. Second element is to store and manage keys. Security is security credentials. What needs to be secured is the key. And the key needs to be managed, revoked, changed. And our job is to make the life of hackers more and more difficult. So they have to spend a lot of time to hack our security countermeasures. That's always security is relative. Risk, cost, how much complex you need to put something together in order that 99% of the population will stop there and say, well, no, too difficult for me, abandon there. And the third element is access control. And access control, authentication between 2 devices, between a device and an infrastructure, or between end users, so me as an end user of my car, but also people at the garage. Only at the garage, only specific personnel can have access to specific element of my car. So with encryption of data, with storing and managing keys, where you can guarantee the life cycle management of security credentials and access control, You have the hand on the data. They are trusted. They are generated by authentic devices, and they are ending up into the final system, not corrupted, not misused, and I can trust those data. But as I have authentication method with other industry, I can give those information, those data, and give and get money, and I can really benefit from security countermeasures of a tool, trusting data. My partner, my business partner, will trust my personal data. So then revenue streams, and new revenue stream will come, and not having different industries saying, no, I don't know your device, I'd never certified it, I'm not sure it's proper data, give me your data for free, but not sure I'm going to use it. While trusting information, while putting trust in the device, in the network, in the data, and in the ecosystem of the IoT, will really not only generate additional cost, but really unlock new business models and allow generation of new revenue. And that's what is provided from strong authentication to data protection, from the edge, all your devices, to the backend system where all the applications are taking care about this data. And just to conclude, and I'm not too late, just to conclude, it's security means everything and nothing at the same time, but it's trust, which is the key thing to build smart infrastructure, and not only to secure one piece, but to secure the device, to trust that device, and trusting that device, it comes with different level of security, with a secure element, with a SIM, with embedded software inside, with using distributed security and using all the computing power that is across the infrastructure. So trusting the device. The second element is trusting networks, and the example of the home, it can be hybrid networks. My fridge is connected through Zigbee to the hub is connected through power line to the concentrator, and the concentrator is connected through GSM technology to the information system. So I have to handle security across these 3 different networks. Not easy if you want to put end-to-end security. Third element, trusting the data. Trusting the data, encryption of the data, authentication of the different devices, and finally, trusting the ecosystem. And with these 4 elements of trust, that where we think that will help the different industry connecting objects, not only living their life with their application, but really leverage on their infrastructure, being able to rent, to sell the data, where lies the value, and then making new revenue streams with their application. Thank you.